Hi, my name's Hans-Peter Arp, and I'm thrilled to be speaking with my 0PM colleague, Emma Schymanski, and her work on the PFAStree. Emma, how are you?
I'm great, Hans-Peter. Great to see you. And how are things going in Oslo?
Oh, pretty good. I mean, it's summer now, and I love summer in Oslo. How are things in Luxembourg?
Pretty rainy today, actually. Full on
Uh,
0 p.m. Talking about water. We can see a lot of water today.
oh, great, great. And what perfect weather for a webinar, actually.
Absolutely.
So Emma, one of the most fantastic developments since we started 0PM has been your work on this truly amazing tool called the PFAStree, which is available through PubChem. And I think it will be an important resource for all researchers looking at the PFAS going forward. And what you're going to do in this video is walk us through it so that people can know more about it, what it is, and how they can use it for their own research. So maybe I'll just, before we get into it, before we go right into the PFAStree, I'm going to ask some questions about it just so our viewers know what they're in for. So first question, can you explain your motivation to develop this PFAStree project, say from the initial idea or spark?
Yeah, sure. So actually the initial spark was probably many years ago. So PFAS and fluorinated compounds have always been a real challenge for computational mass spectrometry. Fluorine doesn't have an isotope pattern. So we were always looking at better ways to cover them in our analysis rather than predicting formulas. As soon as you add fluorine in, you get thousands of formulas. So we then started on the suspect lists. So we started collecting different suspect lists of PFAS, and we noticed that some lists had tens of PFAS, and then they started growing, and then there was a list of 3,000, and then there was a list of 5,000, and there was a list of 8,000. Then I started talking to my PubChem colleagues, and he's like, no, it's more like millions. And then the new definition from the OECD PFAS came out with just a CF2, and we started doing some substructure searching, and we went, yep, it's in the millions. It's not in the thousands anymore. And this kind of started us thinking, okay, how can we present this information in different ways to people to help them explore it, to help realize how many of these compounds are actually out there? How can we support this current debate about PFAS, what they are, and how to move on to alternatives?
Wow, that's amazing. And I remember when you first presented that to us, like 6 million PFAS, I remember the number being, and that, I could hear everybody's mind being blown because like this is not a number we're familiar with. And what's cool is you're going to explain now, I think, how we get to this number. But maybe one other just question just about how the origins, say the origin story of the PFAStree is that you involved the talented people at PubChem and also a lesser known company called Entrez-tained. So maybe to help develop this, so maybe just talk about their roles and their involvement in this project.
Yeah, sure. So for the PFAStree itself, the vast majority is done between us and the University of Luxembourg and the PubChem team. So it's hosted on the PubChem infrastructure, and I'll give a tour through, like you said. With what the key to the success of PubChem is that they integrate data from different sources. So my first interactions with them was as the norm and suspect list exchange, integrating suspect lists through there and integrating them progressively into PubChem. And this is kind of where Entrez-tained comes in as well. And I'll show in the tree we have the different data sources. So Entrez-tained are a cheminformatics company in Germany, actually, and they work together with Google to do extraction of data from patent documents, from literature resources, working with Google, of course, to get search infrastructure for chemical information in the internet. And this has been also super interesting because PubChem is made up of all the data we have. We know there are gaps in PubChem. We know there are gaps in all the resources. And so really cheminformatics companies with huge infrastructure like Entrez-tained, having them as a data source from one set of people, having the researchers, which is what we're getting with Comtox and with the normal suspect list exchange. Also from all the other PubChem contributors, they have 850 plus contributors by now, probably 860.
Wow.
That's a lot of information. So we're based really heavily on the PubChem infrastructure and their functionality, and you just see how much they have to offer. But it's integrated out of so many researchers' different work.
So amazing, and so amazing how like cheminformatics and these great cheminformatic resources are just booming and exploding and getting like the whole community active, involved with all these new actors. It's so amazing. Well, I think we talked enough about building up the PFAStree, so maybe now what we can do is the screen is yours. You can open PubChem in your browser and just walk us through this amazing tool. Screen is yours.
All right, I'm trying to share. All right, can you see the Pubchem browser now?
I
Awesome.
can see.
All right, so here we go. This is the Pubchem Classification Browser. So you'll see here, hosted by the Pubchem infrastructure. Pubchem actually have a lot of different classification trees. So here, this number is telling us we're the right one, 120. And you'll see here we get the classification tree and a little bit of a description. If you actually click on more here, you'll find directly a link to our documentation. So if today's walkthrough is not enough, you want to find out more, we have a lot of documentation with more information here. You can actually also get to the same documentation at this link out as well. So this will actually open up the PDF in a new window. And once it's loaded, it's a big tree, so it's a big document. You can actually see all of our updates with lots of hyperlinks to knock yourself out and get more information. And if you're missing anything in this documentation, we're always happy to add more details. But anyway, enough about the documentation. Of course, you have to document everything, but what we're doing today is showing you the tree. So as you scroll, again, you can see the repetition of our title. Every time you see a little question mark, you can actually get more information about each of these categories. So this will just describe the tree. And then for each of our subcategories, we have this as well. Wherever you see this little arrow, it'll be a link out to more information. So yeah, as I said in the motivation, we actually started all of this with what we call the PFAS suspect list. So this was my original involvement with Pubchem, started with this Norman suspect list exchange. And you can see here, even though in the beginning we only had a couple of PFAS lists, now we've already got quite a few. So PFAStree, this is from Ksenia Trier. I just met her for the first time at CTAC actually a couple of weeks ago. This is fantastic. From Chemi, OECD PFAS, this has been obviously a huge effort by Tanyong Wang, our fellow 0PM colleague. This was actually where Tanyong and I first got a little contact together. So yeah, this is what I was talking about before as well. We have the lists with the numbers of PFAS in the few thousands. We also started integrating the content from CompTox as well. And CompTox have even more lists than the Norman Suspect List Exchange, so they're well over 30 lists by now. So here in this section of the tree, you can really browse these different suspect lists. We have also, as you mentioned, OntoChem as well. So in our OntoChem article, we looked at different definitions of PFAS, whether it's CF2 or whether some slightly more restrictive definitions, and you can explore the different numbers of possible compounds here. The extraction from the patents is a huge challenge for Pubchem, for OntoChem, for all sorts of companies. So this is also why we've been exploring how to extract this from patent data, what structures come out, and how can we actually curate that so not too many difficult structures come through, let's just say. We also finally just added some other fluorinated chemical content in Pubchem. And just a little bit of a teaser, there's this great new list from NIST coming up soon as well. We just deposited the data last night, the day before, and in a few days, this one will also be out. So as soon as there are more collections out there, we're happy to add them in. This NIST data actually has about 1,000 new CIDs. So even more PFAS coming very soon. So yeah, this was our PFAS collection. Now we want to get on to the exciting bits with the 6 million, our OECD PFAS definition. So this was this new CF2 definition that came out a while ago. And as we already discussed, this was this ginormous number of 6 million. But you can see if we expand the tree, then we've separated this out into different categories. And a lot of this 6 million is actually just molecules containing one single CF3 group. And you can see here that's 5.4 million. We've also got a lot of molecules containing an isolated CF2. So this expansion of the definition to aliphatic CF2, CF3, this has really expanded the PFAS space a lot. And then you can see in this final category, PFAS parts larger than CF2, CF3, this contains also the PFAS that are covered by the more classic definitions as well. So good to know for the CF3, this is a lot of drug discovery. There's a lot of this drug discovery content in Pubchem combinatorial libraries. This is what makes the numbers so huge, but also a lot of them were not produced in amounts that we'll find in the environment. What we can also do is break down even further, and then you can see whether it contains an isolated CF2 and bigger parts, or if it only contains an isolated CF2 or a CF3. So we've got an extensive breakdown going through as well. And again, you can see the vast majority only contain isolated CF3 groups, but there's still 25,000 containing CF3 and larger PFAS parts. And then you can expand it even further and find out what types of parts contained within there. So let's just collapse these back down, because here when we get to the molecules containing the larger PFAS parts, we also have a different breakdown by the count of parts. So whether we've just got a single PFAS part in there or multiple PFAS parts. So if you can imagine, this is going to break down into multiple different PFAS components in different directions. Or we also have here the breakdown by isolated PFAS part type, whether it's branched, whether it's cyclic, whether it's linear. Yes, we've even got a single singleton. It is all PFAS, nothing else. So there's all sorts of fun here. And then once, you know, it's 6 million. How do we browse this? We have a really comprehensive breakdown. So let's just look at the linear ones, because these are obviously pretty interesting. You can start to see here we've got the count of molecules. So even within these categories, we've got over 10,000 CIDs matching this particular category. So it's the linear ones. So if we would want to, for instance, say how many C4, F9 linear PFAS are in PubChem, this is still a huge number, 10,500. What you can do is then click on this number. It'll open up a new window. You can see here at the top contains one C4, F9 linear group. And then amongst the search results here, you can browse and find out all of your classic PFAS. And then as you go down, you start to see all of the different variants that have this group in there. So the great thing about this is you can also use all of the PubChem functionality here. You can set different filters. Takes a bit of a while because it's 10,000 groups, but you can start to filter this by different properties. You can go and have a download file. You can sort it by different criteria, so relevance, the CID, whether it's a very new PFAS, whether it's old, all this kind of thing. Log P, if you've seen at the bottom there. We can also get a download file. In the download file, you get a lot of different annotation information. So this also helps you see how many of these PFAS have been contributed by different people, or was it just a single match from a patent? If you click on the individual records, you find this too. I'm going to show this push to Entrez functionality a bit later. I know Hans-Peter's got some questions for me. We'll show that there, but this pushing to Entrez functionality, this is really the way you can start interrogating these PFAS a lot more. Before we go on to that and all the different questions, I'm just going to look at a couple of different parts of the trees, because I know Hans-Peter got excited about a really new feature. But before we go into that, we have the OECD PFAS, and then within the same OECD report, they also did a breakdown on organofluorine compounds. So here we can expand not just the PFAS, but what also has fluorine in it that's still organic, but not necessarily meeting the different PFAS definitions. And here again, shocking number, 19 million organofluorine compounds in PubChem. This is just a huge challenge to browse. And what we did is we actually took an image from the OECD PFAS report. Bear with me, I'm just going to change tabs. So they had in their figure 8 of their monograph, we were basically inspired the categories with this. Everything in the gray is not considered an OECD PFAS, so it's not meeting the CF2 definition. Everything in the blue is. So everything in the blue is also in our OECD PFAS section, but everything in the blue and the gray is in our organofluorine section, split up according to these categories. So again, here we've split them into aliphatic and aromatic, because the aromatic, you can see here, 18 million. A huge number of these 19 million is actually aromatic substances with a PFAS chain. So I can see Hans-Peter's just shaking his head at these numbers. It's incredible. So
dizzying.
Yeah, it's dizzying. I'm not going to go through these in details, but these categories match up with the OECD. And then we had to add in this tiny little, it started off tiny. It started off with only 500 in it, and we're up to 84,000 already, of other fluorinated substances that didn't quite fit into the OECD report. But you can see here, because we're in the organofluorine compound section, these are still just other fluorine, but connected to organic compounds. And we've clarified here what we're calling, what we're calling the organic. It's basically the 11 organic elements of the periodic table. The latest and greatest that we had, because we noticed this was only the organofluorine compounds, was we had a lot of diverse fluorinated compound in PubChem. So in this section, we started exploring these other fluorinated contents. So we've got fluorine bonds connected to non-carbon element. And again, we've got a breakdown by the number of molecule matches. You can see here, boron is very popular, of all things. And then here, there's even hundreds to thousands that have fluorine aluminium, fluorine arsenic. Again, we've got the organics repeated as well, so FP bonds. And then we've also got a breakdown by containing a non-organic element. And again, this does the same thing. We just do a breakdown by the numbers. Boron is again extremely popular. And then, like you say, anything containing a selenium atom that's also organofluorine. And then we can sort it actually by the number of fluorine atoms as well. So you can really see, okay, it's only got one fluorine. It's not a CF2 or anything highly fluorinated, but you can see there's also some with a lot of fluorine atoms in there. Once you start browsing these, you'll just get blown away at the different fluorine chemistry that's out there. So I think that was a 10-minute tour or so.
Yeah, no, that was really amazing and incredible. And yeah, and a lot of questions I think come from this, like different structures and what structures are the most common. But maybe just a question before I get to the next question, which you planned for this. You didn't plan for this question, but when people see these numbers 6 million and they ask you, yes, but how many of them are actually produced in the environment? What would be your answer to that question? There's different numbers around.
There's a lot of different numbers around. So this is also why we put in these lists so that we have what the experts consider as PFAS. I'm going to semi-answer my next question already, but okay. we can do 2 demos with this. So PubChem also have, I mentioned that they have a lot of different classification trees. This one is their table of contents. So this is actually a content of their records, of the individual records. So these are actually what you see here are the headings in the records. And you can see here there's a great one called use and manufacturing. So what we can do is we can actually search these 108,000, for instance. And then we're going to push this to Entrez. And it doesn't hurt to do this search a couple of times because the Entrez is super powerful, but it's very complicated. And what we're going to do is we're going to go back actually to our PFAS tree. So we're at 120. We're going to press refresh. This is where the magic starts because now you can see we've got a new entry here, filter by Entrez history. So once you've done an Entrez search, you will see this history and you have to memorize the numbers a bit. So we've got the 108,000 from use and manufacturing. So it's this one. And you can see what it's now done is it's actually only displaying entries in our tree that actually have use and manufacturing content in PubChem. So yes, like you said, we've got 19 million organofluorine. We've got, what was it, the 6 million OECD PFAS, but we've got only documented use and manufacturing information for 4,700 of those. And
much more manageable.
Much more manageable, yeah, and much more manageable download file sizes as well. If you want to download those 6 million, it's going to take a lot. But yeah, exactly the same thing. And once you've done this this breakdown, you can actually also send this straight to the search window and download those. And then you've got the overlap of all of the larger PFAS parts that also have use and manufacturing information in PubChem. Also worth noting that a lot of this use and manufacturing information has actually come directly from our 0PM colleagues, so Sanyong Wang is one of our PFAS contributors, the Juliana Glüger list that we've worked up with PubChem as well, with 0PM as well. A lot of these have actually been feeding in this PFAS content into this section.
No, excellent. Really, and it's really good. This is so 0PM will give and get a lot from this PFAS tree for sure. Yeah, but maybe let's give a more concrete example. So let's just say a theoretical scenario that there's a student looking for PFAS in agricultural chemicals or PFAS monitored around farms or things like this. How would they get a list of suspect PFAS to look for in their research using this great PubTree tool?
Absolutely. All right, let me close this window. So again, we can go back to our favorite PubChem table of contents tree. I have many favorite trees, I should say. Of course, the PFAS one is too. So you can see here we've integrated a lot of agrochemical information content. And what you can actually see here as well is where a lot of this information is coming from. This is why I actually like going through PubChem so much. But when they have the content, it's actually in the record, so you can go back and verify why this is of interest. So a bit of trivia is all of these transformation annotation actually came directly from the Norman Suspect List Exchange, but you can see they've integrated EU pesticides data, the US pesticide data as well. So again, we can do the same thing. We can put this whole category into Entrez. And again, we can push this to Entrez. we go back to our tree, do another refresh. And I hope everyone remembered it was about 3131. It's a lovely number. I like number patterns. And then you can see here we've actually got a lot less. We've got 299 that meet the OECD PFAS definition that are also agrochemicals as well. And same thing, you can just send that 299 off, get your download file, and then you've, because I'm only showing my browser, the download is not going to work to show you today, but it's in our documentation that actually contains all of the smiles, all the Inchi keys, the formulas, the mass, everything that you need, plus all the annotation content, who were the data sources, what other information is out there. So the download file is, contains a wealth of information. And here, of course, you can browse them straight away, and you can see actually already a lot of them are CF3 groups out of here. What you can also do, of course, is go to the breakdown that we have. So look at this. This is really interesting. There's actually only 2 of them that have a PFAS part larger than a CF2, CF3. Isn't that interesting?
Can we see them?
We can see them, of course.
Yes.
And there they are. Yeah.
Yes, known ones. Oh,
yep.
Wow.
Well-known ones. Yeah.
Very cool. No, this is amazing. So I hope the viewers of this video that thanks for watching this whole video. This is great, and I hope that you might get inspired for your research and how you can use the PFAStree. So I think this will indeed change the game. So anything else you want to say about the PFAStree, Emma?
I was going to say we have plenty of documentation. I'm just going to flip back to it. Within that, we've got our contact details. If you want any more information, check out our documentation. If you're missing examples, let us know. We can write them up, and please give us feedback about this tree. We're really enjoying doing it, and we're happy to add more features, and there's much more coming soon.
Oh yeah, no, and I'm loving it. I mean, I can get totally lost in the tree, but I'm a chemical geek, so that's what we do. So very cool. Yes, so thank you very much for this, Emma Schymanski. And so this has been a video from 0PM, protecting human health and the environment from persistent and mobile organic substances. For more information about 0PM, please visit our website, 0pm.eu, or subscribe to our YouTube channel or newsletter, also at 0pm.eu. Okay, thanks a lot for watching, and goodbye. Okay, I think that was good.
Awesome.
0PM, Zero Pollution of Persistent and Mobile Substances. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under Grant Agreement number 101036756.